Hello everyone, welcome to Tech with Machines. If you are new to the channel, please like and subscribe. And if you are already visiting the channel, please remember to subscribe. I welcome you all, and today's topic is going to be a very simple topic, aggregations in Spark. We are going to actually discuss about very basic functions which we do perform in our day-to-day if we deal with databases, and how we can do exact same thing in Spark as well. Now I have broken this concept into three videos. In this video we'll only talk about very basic aggregations, and in the next video we'll talk about the grouping as well as the window functions. So that if you are a beginner, you can really understand first how you do these things in Spark before you can jump into the complex aggregations or deal with complex aggregations, specifically the window functions. Now, what really, if you are new to this concept of aggregation itself, then what really aggregations are? Aggregations are generally about collecting data together and is mainly useful for getting some information or some stats about data or analytics about data. Generally, when you're aggregating, you can specify a key or a group and an aggregate function to product result for each group. So for example, you want to do a simple counting. So you will do it on a particular, either you will say that I want to just count all the rows, number of rows which are there in that particular data set, or you will say that I want to count a specific column in that data set and how many unique values that particular column has. Or you might say that okay, I might want to get the unique count, but it should be grouped by a particular column. So there are many ways, there are many aggregations which you perform to do those kind of a data analysis and understand about data. Understand about if your data is skewed or if your data has the variance of if two columns has any correlation between them. So we are going to first go through the basic functions, and we will discover them with the problem statements instead of going directly into that aggregation function. We'll justify that aggregation function with a problem statement. So what I have done is I have created 7 problems here, which are very basic problems. You might already know it, but it's very important. If you don't know, you stick till the end in this video, and we will solve them one by one. What I have done is I have actually used a retail data set. You will find it in the Spark definitive guide GitHub link. I usually am using all the data available in that GitHub, and using that data we'll do actually different kind of functions, aggregation functions, count, sum, minimum, maximum, standard deviation on this. So the first question, it says that we have been given a retail data set. We need to find the total number of rows. Now it is followed by a bonus question as well, that while doing so, what is the difference between doing count star versus count of a specific column? So let's get into how we can solve this and what really is the difference between count star versus count of a specific column, right? So let's start our first problem statement, which was that find the number of rows in a given retail data set. So what I've done here is, as I have started the Spark session and I am reading the that retail data set, which somehow looks like having these columns, which you can see. It has invoice number, it has stock code, it has description, it has quantity, it has invoice date, it has unit price, it has customer ID, and it is country. It is a very interesting data set which we are using here, and there can be multiple problem statements which can be created on this data set and help you to understand the aggregations in a much better way, right? So first, very basic example which we came across is just do a count star, right? Really what you are doing is count star, which you do in an SQL as well. And surprisingly, because I have not yet talked about it or shown it in any of my videos. Here I am doing one thing which is slightly different. I am creating a temp view on a particular retail data set. This basically is actually creating it as like any SQL table, and I can fire an SQL query on that particular table, right? As you can see, line number 12, I am actually doing a create or replace temp view and giving the name of the table what I want it to create, and then I'm simply firing if I will fire a simple select star query with only 5 rows to be shown. So that's what it is doing, right? Also, one more thing which I have done here is when I'm reading the retail data frame, this data is about around 40 MB. So what I did was generally that when I loaded it, I am actually reducing the partitions by calling coalesce. So we went through that. If you remember, repartitioning and coalesce. So that is helping me to basically avoid any kind of a shuffling here, and also on top of it I'm caching it so that the processing is much faster, right? Because it's just 40 MB. Now as our first problem statement says that we have to find the number of rows, so let's see what we can do. If you remember, we have a count as an action which we can perform on data frame, and that is gonna give us the number of rows which this particular data frame has. So if I do just retail data frame dot count, it actually is an action performed, and it's gonna give me the number of rows this particular data frame has, which is around 541k. But this is an action. Now what we are gonna do is we are gonna use count as an aggregate function, and we will use it as a transformation instead of as an action. Now how it can be used as a transformation instead of an action, let's figure that out. Generally all the functions which we will use are actually available in a package called pyspark.sql.functions. So you'll find all functions here. So let's first import count, because that is our first function which we are dealing with, right? So what we are going to do is we are going to use select along with the count. So what we'll do here is, let's say if you are firing, let's do first a simple Spark SQL query. Let's say if you were given the same problem statement and you had to count the number of rows this given data set or given table has. So what you will do really is you will actually write a SQL query using count function. So what you will do is, and because I have created it in Spark as a view, so when you are firing a SQL query, you have to really load a SQL context. So that's why spark.sql. So we are saying spark.sql, and what I want is give me the number of rows this particular data set has. So this is going to give me, and the name of my table is actually retail table, and this is going to give me, and here the count is being used as a transformation. So this is giving me a count which is same as what I did with an action count, right? So this is how you write it as a SQL query. Now if you have to write it in the Spark code, what will you do? So you will say retail data frame. So we're going to deal here with retail data frame, and we'll say select and use the count function. Now because we want to do count in all columns, so we'll do count star and say dot show. So sorry, now here what we are gonna do is, one minute. So what we are gonna do is quote it and say count star, and this is going to give us the same thing which the upper query gave. Now one more thing which we could have done is, instead of doing count star, we could have just counted one particular column. So we'll say select retail data frame dot select count, and now one of the columns here is, let's say, stock code. So we'll say count stock code dot show. So here, if you remember, we are using the string way of selecting a column, and not really call function or column function object here in this case, right? So this shows us that okay, we have a way of selecting number of rows, selecting the count of rows of a given data set by using the SQL context or by using the Spark. Now, what is the key difference between count star and count of a particular column? The main difference between two is when you are doing count star, it generally will actually also include if there is a particular row with all null values. Whereas when you're doing a particular column, it will drop those null values. It will generally select the only count the values which are non-null. It will actually not count the null values, right? Whereas count star doesn't do that. It also counts and includes the null values. So that's what is the key difference between doing a count on all columns versus doing count star versus doing a count on a specific column, right? Now let's move to another problem statement. So our second problem statement says that given a retail data set, find the unique count of rows. And if you have to find approximate distinct count instead of distinct count. So basically what we want to do is, one, as we did in the first problem, we actually basically counted the total number of rows, total count. But now we want to find the total unique count or total distinct count of a specific column. Generally it will make much sense of doing it for a specific column, that you find the total distinct values which that particular column has. Or we don't really need the exact distinct count, even if there is a little bit of an error or an estimated error of 1%, 2%. I just want an approximate distinct count. So that generally happens in analytics. When you are dealing with a large data set, you really don't care about the exact numbers, or what you want really is that how far or how near you are to the exact count. So it would maybe matter more to get the approximated count than the exact distinct count, because that generally will be faster comparatively if you're dealing with a larger data set. That's why there is an add-on to this particular question, that instead of doing a distinct count, give me the approximate distinct count. Now, what are the functions which are used to solve this problem statement? Let's go through that. So now let's deep dive into problem statement 2, which I just wrote it down here so that we don't have to do back and forth. So what it says is that find the distinct count of stock code in given retail data set. I specified the column on which we want to do this in given retail data set along with approximate distinct count. So if you were planning to write an SQL query, what you will really do is you will do count distinct of that particular column, right? So let's say I wanted to do that, then I'll do select count, use the distinct method in that and provide the column name which we have, which is stock code from a retail table, and really you will execute this, right? So I haven't called any action here, so we'll say show, and this should ideally give me the distinct count of stock code, which is around 4070, right? But if I had to do the same thing in the pyspark, I will actually there is a function called count distinct in the same package which we just used for count as well. So what we are gonna do is we are gonna say from pyspark.sql.functions import count distinct, right? So we are gonna really import this particular function from distinct from pyspark. Also, as we are going to do approximate count distinct also, so let's load that as well. So we will import actually approx, and that function is actually approx count distinct in the Spark. Approx count underscore distinct in Spark. So these are the two functions which are there in the Spark. Okay, so let's do that on the retail data frame. So first we will do retail data frame dot select, and we'll select the count distinct function, and we'll give the string representation of the column, which is string code, string name, and say dot show. So now this is going to exactly give us the same thing which it did in the previous SQL version. Now if I want to really get the approximate distinct count, I will say retail data frame dot select approximate count distinct and give the same column reference, stock code, and do dot show. Now there's one more thing with the approximate distinct count. You can actually pass the error percentage you want. So like in this case, let's say we want 1%, so we'll say 0.1. So with this, it is actually reducing the count. It's not exactly the same count, but it is getting us the approximate distinct count, right? Maybe let's work with a different estimated error as a second parameter. So let's say it's a 0.1 error which we are looking at. So we will basically do this, and this is specifically giving us pretty much closer here and there to the approximate version, right? And if we would have done it 0.3, then it is giving us somewhere closer to 4070. So this is how you actually count the distinct or approximate the distinct count in PySpark. Now let's go through the problem statement 3, 4, 5 and further 6th and 7th. So we'll just club them together and understand what really we want to do. So problem statement 3 says that I want to find the first value of a given column stock code, as well as along with it an add-on is that also return the last value, right? Also, what we want to do is we want to find a min max of a given column called quantity in a given retail data set. Also, along with it, we want to do certain other aggregations like sum of the quantity, distinct sum of the quantity, or average of the quantity. Along with that, I also want to do basic variance and standard deviation which that particular column might have. An add-on is that we should be either using the sample and the population standard deviation. So there are two types of the standard deviation generally based on the different sampling models, one being the sample and another being the population. We might get into details if you want, or you can find the references in net as well. So sixth question is very common for the data analysis, for the data analysts or data scientist people, where they actually want to find and understand the skewness, if at all, abnormality or any kind of a disparity is there in the data, right? If there are abnormal values in the data and they are not consistent, so data skewness needs to be found. And along with the skewness, it also needs to find another term called kurtosis. We'll go through that as well. What does it really mean? Along with it, we also want to do the covariance and correlation between two columns, invoice number and the quantity. And again, when we are doing covariance, like we want to do variance with sample and population, we also want to do covariance with sample and population. So these are in general the another 5 questions which we are going to go through. So let's start with them one by one and see what kind of functions are available in Spark to deal with them. And remember, even though we are doing them one by one, there might be a problem statement asked, or you might encounter a problem statement in your day-to-day work where you will have to use them in general in combination to get the exact data. So they are very important functions. They might seem very basic, but they are very important functions to understand the basic analysis or analytics you can do on the data, right? So let's go through them one by one without any delay. So I've noted down all the problem statements which we just went through, the 5 problem statements. So beginning with the third problem statement, which was find first and last value of column stock code. So for this in Spark, we have functions like first and last. So if you would have to do it in SQL, you will have in SQL as well the first and last functions. So from pyspark dot, and again it lies down in the same package called functions. So you will import first and last from functions package. We'll run this, and now finally what we'll do here is we'll basically get the first from the retail data frame. We'll do select and we'll call first on stock code, and we'll also do last on the stock code. So let's do this in two things which we want, last value and the first value, and let's do the show on this. So it actually returned us the first value and the last value of the stock code, right? So this is as simple as that, where you want to do first and the last. Now the fourth problem statement is very basic aggregation question being asked, where you want to do the maybe you might have another data set where you're talking about transactions, and you want to know how many transactions were placed, what was the minimum transaction amount, what is the maximum transaction amount, what was the average transaction amount, and if there was a distinct total count of those transactions, right? In a similar way, we are doing here on the quantity column in this particular retail data set. So for min, we have a min function. For max, similarly, we have max. So we will import them. So we have min, we have max. For sum, we have sum, and for distinct sum, we have a function called sum distinct, and finally for average, we have average. So sum distinct, and then finally we have average. So let's import them. We have imported it. Let me add new line here so we can actually write the Spark code here. Not really here, we have to add it prior to this. Okay, so now we want to really do min, max, sum distinct, and average. So let's do everything together. So what we are going to do is we're going to say select, and we will say that I want to have actually the minimum of my quantity column. So we'll say quantity minimum, and we will say quantity maximum, we'll say sum of quantity, and we will also say sum distinct of quantity, and we will also gonna say average of quantity, right? And then let's do the show on this. Okay, what did happen? Okay, sorry. So we have it as retail data frame instead of data frame. So let's do this, and as you can see, it's actually doing and again you can see that sum distinct is generally deprecated. Instead sum underscore distinct in 3.2 it's deprecated, so we can also use sum underscore distinct instead. So this gave us the minimum, maximum, sum distinct sum, and the average of the quantity in general, right? And now let's find that how much variance is there, how much standard deviation we have in the particular data set, right? So variance is generally, so basically both of them actually is talking about the spread of the data around the mean, right? How far or how near you are, how distributed you are actually. So variance generally is the average of square differences from the mean, and the standard deviation is the square root of the variance. Now you don't really need to calculate it from the scratch. You are given the functions which actually does that for you. So you have functions like variance, called it as var, but then again variance has two different ways. One is variance sample and one other is variance population. Same for the standard deviation, you have standard deviation population and standard deviation sample. So we'll do both. So what we are going to do is we are going to import variance sample, we are going to import variance population, we are also going to import this standard deviation sample and standard deviation population. So these are the functions which we are dealing with. So let's add another line here, and we are going to use them on the retail data frame. So we'll first use variance sample on the column quantity, and we will also do variance population, just that there are two different distribution methods to check the variance. And for population, again we are going to do on the same column quantity, as well as we'll do standard deviation sample again on the same column called quantity, and we'll do the standard deviation population on the same column quantity, and finally we will show the results. So this is how you basically create the variance and the standard deviation in the, sorry, this is wrong, so we'll correct this. And this is how you actually create the standard deviation and the variance. So generally you see there's slight difference between both of the ways, being the sample variance or being the population variance, right? So this is about how you can calculate variance and standard deviation. Now comes skewness and kurtosis. Now, they are both measurements of extreme points in your data. Generally, skewness means that the disparity or the asymmetry of the values in your data around the mean, whereas kurtosis is a measure of the tail of the data. They are both relevant if you are modeling your data as a probability distribution of a random variable. So we might not go behind the math of these functions, but you can calculate them by using these functions, and you will easily find the definition on the internet. I'm just trying to give you the possible functions with which you can actually create or understand the abnormality around the mean or around the tail of the data, right? So there are two functions which are available in Spark. So one of them being skewness and another being kurtosis. So from pyspark.sql.functions, we are going to import both of them. So we are going to import skewness, and we are also going to import kurtosis, right? And let's actually find it. So we are gonna do it in the same way. We'll do select, and we will call skewness on quantity, as well as we'll call the kurtosis on quantity. So finally we will do show here, and this is going to give us, just 1 minute, we are going to again load this, and then we are going to fire this. So this is how it is telling us that how much skewness and how much variant it has been around the mean, or it is far from or around the tail of the data, right? Now important one is covariance and correlation. This is generally used for the data analysis, right? And they are very important functions. So covariance also has two ways. It has sample and population. Again, we will use the pyspark.sql.functions, and we will import one being covariance sample and other being covariance population, right? And finally we will have the correlation as well. So what we are going to do is we are actually going to find the correlation and covariance between two columns called quantity and invoice number. So what we are going to do here is that we are going to say retail dataframe dot select correlation as first function. So we will do correlation because we are doing two correlations only on two columns. So here we are doing it on the invoice number and quantity, as well as we will do covariance using the sample distribution. So we'll do samp, and here again we are gonna give it both the columns, invoice number and quantity, and then finally we'll do covariance population, right? And we will basically give it again both the columns, invoice number and quantity, right? And finally let's do show on this, and this is going to give us the covariance and correlation, right? So this summarizes our today's session and today's video, where we talk about the different functions which can be used, the different basic functions which can be used with certain problem statements and certain add-ons. I hope you liked the video. Keep learning and happy learning.